It's hard to exist in the world today without encountering artificial intelligence. In ways large and small, an increasingly complex array of algorithms and data-driven insights are helping to drive policy and shape the world in which we live. That's no less true for migration. A growing number of international organizations and governments and nonprofits have started to explore how AI tools can compile and analyze huge amounts of data to help predict future migration, including climate migration, in order to more effectively protect people at risk and manage future movement. This is Changing Climate, Changing Migration. From the Migration Policy Institute, this podcast is dedicated to exploring the complex ways that climate change is driving migration. My name is Julian Haddam. I'm the host of this podcast and the editor of MPI's online magazine, The Migration Information Source. Check us out at migrationinformation.org. My guest today is here to help me resolve a big question with a complicated answer. Can AI predict climate migration? I'm speaking today with Dr. John Auga. John is a data scientist at the University of Louvain in Belgium who specializes in machine learning, and he was the lead researcher on a project looking at how AI can help analyze existing climate-related migration and predict future patterns in West Africa. John, thank you so much for coming on the podcast today. It's great to have you.
Thank you for having me.
In very simple terms, how did you do your study? What questions did you ask? What sort of data did you put in? And how did you analyze the numbers that came out?
Thank you for that question. So this research was mainly done using a dataset called Gallup. And the Gallup dataset is, let's say, a survey that they do around the world in almost all the countries. And they ask more than 2,000 questions to people about many things. And so the part that I was interested in that research was mainly related to migration, but mainly here, it's not if people really move, it's mainly about intention to move.
Mm-hmm.
And we combine that then with climate data that we have, but we don't look at all the climate, let's say, futures. We mainly focus on shocks like droughts and also floods.
And you looked at, 7 or 8 countries in West Africa and the Sahel a little bit, right? What countries did you look at?
Yeah, so we look at Senegal, Mauritania, Niger, and Ivory Coast countries. So we look at 6 countries, actually. And why we were mainly looking at those countries, it was because we realized that, for example, if we look at, let's say, other countries around the world where they use technologies in agricultures, we were not able to capture the real impact of climates on the migration or on the economy, where those countries, mainly West African countries, has first agriculture as the main economic driver, but also they are still using, let's say, basics techniques in agriculture, which are mainly based on climate movement, based on season, actually.
Mm-hmm.
That's why it was interesting to look at them.
Sort of climate vulnerability, especially for agricultural dependent communities. Some overlap with climate impact, I guess. And before I get to your findings, I want to ask very briefly about the machine learning aspect of this. So I acknowledge I am not a data scientist. Many of our listeners are not data scientists.
Mm-hmm.
In, I guess, to clarify, in very simplistic terms, how can you explain what you did and how the correlation between migration intentions and climate shocks? What you did there, what is machine learning? It's a subset of artificial intelligence, right? And I guess how did you extricate the answers?
Mm-hmm. Thank you for that question. So I can say that machine learning is something that we all do, actually. When you take something, maybe a phenomenon happened, what you want is to have a way to reproduce that event. So to be able to do that, in our case, we use data, and then from data we want to derive what we call model, and the model will be something we can call, for example, if I'm thinking about mathematical formulas, it could be just a formulas where if I put a y, an x, then we can get a y. So, but here X can be really complex and Y can also be really complex. For example, that can be an image that I give to my model and I want to predict if that image contains a cat or a dog or something like that.
Mm-hmm.
Now, in our case, what we want then is to use data to find a model that will be able to say, for example, based on the weather conditions, mainly shocks, if people will migrate or not, based on some features like age of the people and others characteristics from the populations. And then using that, what we will do mainly is to pour the data to the systems and then find that model. And whenever we have that model ready, then we can try them with new data, with new examples that we will submit new people information and see if they will move or not based on that.
What did you find? What did it say? I guess what is the connection between climate shocks and migration intentions in these countries?
Mhm. So thank you for that question again. So the first thing that we realize that, so even if we are not looking to climate change, we realize that our many works before, we know that, for example, age, gender, incomes, all like will influence the way that people will decide to move or not. But what we realize that even with the climate shocks, those features are always here present, and
Mm-hmm.
then they are like more like exacerbate with that. Like
Mm-hmm.
they will matter more with the climate shocks. We were like studying two kind of intention: short-term intention to move like around 1 and 2 years, and
Mm-hmm.
long-term intention to move more than 5 years
Mm-hmm.
intention to move. And we realized that for the first one, really really short shocks, for example, let's say a harsh time of rain or something like that, can influence like small short intention of people to move. But then long term droughts, for example, will influence people from long term like to move. But something that was really interesting is, if the category of people is between 15 and 24, they always want to move.
Mm-hmm.
Like even if it is for short or long term, they always want to move. But then if you have people now like from 35 and 49, that will depend on like if the climate condition continue to be really like hard for long term.
Mm. So the older people are, the more likely they are to be affected by, or
Exactly.
the longer
Hmm.
the climate shock has to
Yes.
be for them to
Yes.
be more impacted. But otherwise, the climate shock is generally exacerbates pre-existing
Exactly.
migration drivers. I guess that's interesting. Yeah. And you said you looked at 6 West African countries.
Yeah.
I guess to what extent can you speculate? Do we think a that these findings, these correlations, apply elsewhere, especially if not entirely global, certainly in other relatively low income, agriculturally dependent contexts? Question A, and then question B. I mean, can we also apply them forward? How much predictive power do you think there is in these kind of correlations that you've drawn?
Mhm. I think that the way to see that young people always want to move and
Mm-hmm.
older people don't really want to move, or that will only be if the conditions are really hard. This is kind of global, I think.
Yeah.
But then if we take, let's say, specificity here, what we realize in the work is that we, at some point, we were like asking ourselves if we can take our results to global, to other countries.
Yeah.
But unfortunately, what we realized that the global model was like performed really poorly.
Hmm.
When we take the model for specific country and then specialize them, they are really efficient for each countries. But then when we want that model to be like efficient for other countries, then it's performed really poorly. So the
Hmm.
takeaways there is it's better to have a specific model for each country for at least specific, let's say, features, because as we realize, for example, if a country use technologies more than another, of course,
Hmm.
the result of the migration intention will be different. Actually,
Mm. So it's really country dependent. The
it's
same
really country
connection
dependent.
in
Yeah.
Senegal does not work in South Africa or Guatemala or
Yeah.
France or Belgium. Okay, interesting. Going forward, do you think that there is a predictive power for future climate events as well? I mean, if there were a drought tomorrow, do you think that this kind of connection would help predict migration intentions?
Yeah, what I'm thinking is, for example, since, for example, West African countries continue to use like really basic, let's say, technology in agriculture and so on, I'm pretty sure that this result, even if the data was between 26 and 2016,
Mhm.
today I think that is still applicable for those countries. And that means that today, for example, if we have really long term droughts in West African countries, or at least countries that have, for example, agriculture as the main driver of the economy, we can use this model to at least predict in the way people will want to move. But then I think that if we want to tackle other countries, we need, like, for example, to make new survey to see how the new climate shocks will influence those new countries.
I want to kind of talk about the, if not the methodology, at least the use of AI and machine learning here for these kind of, I guess, what are the benefits of using these technologies for drawing these correlations and making predictions versus more traditional approaches that were perhaps,
Mhm.
yeah.
So I will say a word first in traditional approaches. So in traditional approaches, what's happened is, for example, if we have 6 features, for example, related to population and climate, what will happen is they will do a model for each feature, and then do meta-analysis to combine those features to have one result at the end. So
Hmm.
one first advantage of using AI tools like machine learning and so on is the way that we can handle many variables together. Like, we don't need to run, in that case, 6 different model and then do meta-analysis. We can
Mm.
use only one model that can incorporate all the variables and features, and more than that, can also capture the influence of maybe interaction between pairs of variables, or maybe more than those. So that is the first
So it's
interesting
both
part.
more efficient and kind of catches the interactions, right?
Exactly.
Yeah. Okay.
And then another benefit will be the way that, using machine learning, we can capture more non-linear patterns that maybe statistical basic model will may miss in
Hmm. Hmm.
general.
Hmm.
And last thing that I can realize, since we are like doing this analysis together, we can also like quickly set up the model, and then find new insights quickly. And also, maybe if we have new data, we don't need, for example, to do all the specific stuff, like say specifically, but we can just run one things
Hmm.
and have the final result based on that.
Are there limitations, both, I guess, of using machine learning and AI, and also more generally? I mean, I assume this kind of research depends on a lot of underlying data that's
Data,
available.
exactly.
I mean, are those data always available, especially in places like Niger, which are political, socioeconomic price problems? What are the limitations that you've come across?
So I can see two kind of limitations here. So the limitation about our work, but also
Mm-hmm.
the limitation about machine learning in general. So the limitation about our work is that we were like focusing on looking into intention, migration
Mm,
intention, where the actual move can be something interesting to look at.
yeah,
But finding this kind of data was hard at that time, and
yeah.
also based on because of ethical maybe view, it is not maybe interesting to get this kind of data. So
Because of an ethical view. What do you mean?
so for example, if we want to understand the actual move,
Hmm.
maybe we have to take, for example, some people, a sample of people in the population, and then follow them for, let's say, 5 years or maybe 10
Mm,
years, and
yeah,
look at where they go, what they do, and so
yeah.
on. And doing that, we can maybe capture some privacy information that
Sure, sure,
is
sure.
not maybe interesting
It's
to
also
people.
logistically difficult to
Yeah,
like
exactly.
traffic. Yeah, yeah,
That,
yeah.
but some a way to make that possible is, for example, to use telecommunication data, because
Mm,
with
mhm,
cell
mhm,
phone
mhm.
information, of course, we can get all those information, but
Mm, mhm, mhm.
telecommunication company
Yeah,
won't give those information
yeah.
because, yeah,
Privacy
because of,
concerns. Yeah.
yeah, GDPR and so on things. So,
Hmm, hmm. GDPR. Yeah, yeah.
but it's anyway, let's say a limitation of our study. But then
Mm.
when we look at machine learning in general, of course, first thing that we can see as limitation is data, because if we need, for example, to capture this migration intention or even migration behavior in a country, we need, for example, to run new survey to get new data from those countries to be able to analyze how the migration will go and what will be the impact of that migration on economy. And but other than that, of course, today, like, using AI, we should also think, we should be aware about ethical aspects of using them, like ecological aspects, energy consumptions, and these kind of things.
Because
But
these tools, just to clarify, these tools
yeah,
require a lot of energy, and
a lot of
especially if
energy.
there's an irony if you're studying climate change, but the tools you're using requires a lot of energy, which is contributing in some ways to climate
Exactly.
change.
And
Yeah.
something else related to machine learning is also the biases. So, for example,
Mm, mhm, mhm.
it happened since we are working with people data, and based on the fact that we do survey and then ask people questions and so on, based on the country, it can also be in touch with some biases, and our model will definitely reproduce these biases.
What kinds of biases? Can you give an example?
So there are many kind of biases when we use machine learning. For example, if I have a data that's let's say, let's take a real application, let's say a biometric application to have a face recognition.
Mm,
If the
mhm,
data is poor with many white skin
mm,
data, then it will be, for example, difficult to capture other kind of skin. You see, so this kind
mm,
of
mm.
biases can be present, and your model will reproduce it directly. So there should be like some analysis of the data upfront to make sure that at least we are like balanced in terms of representation of each class of population that we are tackling.
That's a great point, and that kind of is a segue to a question I
Mhm.
wanted to talk about, which is the use of machine learning and AI, both for research but also for kind of policy making and for managing migration. I mean, even in the absence of climate-related impacts, there have been an increasing number of efforts by governments and
Mhm.
international organizations to use AI software to predict and manage migration, both to predict irregular migration and you imagine who's going to come, how many people, what to do with it, and also some AI facial recognition and other technologies to facilitate entry.
Yeah.
So I guess there's also I don't know if it's a tension. It's one thing for researchers to deal with these technologies and to try and learn from them. Are there differences when these kind of technologies are in the hands of governments? Are there more ethical considerations then? And I guess, yeah, what are the promises and perils of these sort of technologies, both for research, but also more generally in for governments and international organizations?
Yeah, thank you for that question. So we talking about ethical concerns, I think
Yeah.
that we can see four, let's say, components here. Biases, we already talked about biases.
Mm-hmm.
Privacy, we also talk about privacy, but we can also talk about transparency and misuse. For
Mm-hmm.
example, transparency will be like at some point we have models that will predict something, but behind the model we don't know how the model were able like to do that prediction, and that's come
Mm-hmm.
with some kind of transparencies, like making sure that what we have in the data is what should be used to have that exact prediction that we are getting.
Mm-hmm.
And misuse, for example, doing that research, it was at some point to help us to help at risk communities, right? But then, for example, if a government gets those information or maybe this model, it can use it, for example, to restrict movement, right?
Mm-hmm.
Because they understand now how intention work and so on. They can use it to restrict movement instead of helping us to help actually at-risk communities. So misuse is also something really important in this doing this kind of research. And
That's great, and that is a great transition to, I guess, probably my final question. We're about out of time. I guess what is the positive use? What is your hope for the kind of the applications of these kind of technologies, of your study in general and other studies like it relying on AI? What are the possible benefits?
yeah, thank you for that question. So, for me, doing this prediction, actually for policymaker in general and also aid organizations, would be, for example, to have a general monitoring of what is going on, for example, per country or maybe per region, where we can use those model over time to adjust intervention to
Mm-hmm.
see where we can prioritize, for example, intervention, where we can prioritize, for example, funding. It could also help, for example, to flag some district or maybe region, for example, to say that okay, these cities or maybe this region has at risk communities that we should mainly care about, and then maybe more sensitive about things. Having, for example, an observatory of the climate conditions on some areas can help to see, okay, based on if we are having more than, let's say, 4 months of droughts, we can say, okay, if we have more than four months here, that means that we
Mm-hmm.
should care more about this. We should take this into account. Maybe if not, maybe we'll have a disaster here and so on. So
Mm-hmm.
for me, so that means we could have observatory to be able to monitor things in order to take good decision. We can also have a seasonal plan cash, for example, funding based
Mm-hmm.
on those conditions. We could use this research also to prioritize where to put more money, where we need to help people and so
That's great. I think we've got to wrap it up there for timing.
on.
We're gonna have to say goodbye. But John, thank you so much for coming on the program today. This was I'm not a data scientist, as I've said several times, and this was very helpful for me in drawing these connections. Thank you for your time.
Yeah, thank you for having me, and I hope that this also help you to understand a bit what this domain work, and I hope I didn't use let's say jargon and were able
No,
to be understandable.
you were great. Thank you. Dr. John Auga is a postdoctoral researcher at the University of Louvain in Belgium. He is a lead author of a paper entitled Impact of Weather Factors on Migration Intention Using Machine Learning Algorithms, which was published in the journal Operations Research Forum. Thank you for listening to Changing Climate, Changing Migration from the Migration Policy Institute. Find all of the episodes in our archives on MPI's website at migrationpolicy.org/podcasts. You'll find conversations with guests about various predictions for future climate migration, impacts in certain regions of the world, and a lot more. If you liked today's conversation with John, make sure you listen to the episode Before the Storm, Getting Out in Front of Climate Displacement, in which I explore how humanitarian organizations are trying to anticipate climate displacement and plan accordingly. Subscribe to the podcast so you don't miss an episode. And if you like what you hear, please leave us a review, in which makes it easier for other people to find us. We're on Spotify, Apple Podcasts, and all the other major podcast platforms. This podcast is just one part of MPI's work trying to understand climate migration. We also have a special collection of articles in the Migration Information Source magazine and lots of research and policy briefs from top experts. All of that is on our site at migrationpolicy.org/climate. Elizabeth Navarro produced this episode, Michelle Middlestat provided editorial oversight, and Lisa Dixon offered additional assistance. Our theme music is touched by Patrick Patricios. Thank you again for tuning in. Once again, my name is Julian Haddam. I'll catch you next time.